All right, in 1.4 we're going to look at functions and examples of function is a relation that assigns each member of x, x's domain, x's inputs, to exactly one member of the y range outputs. They all mean the same thing. If any input value matches with two or more output, it's not a function. There are 4 ways to represent a function: verbally, numerically by a table or a list, graphically, or algebraically in an equation. So determine if the following are functions. How do we know if something's a function? Okay, we can find the slope, but what if it's not a linear equation? What did you have here? If it passes a vertical line test, we'll use the vertical line test if I actually give you a graph. What do we do if I give you either a table or a set of ordered pairs? Yes, we look at the x values. So I'm going to, or the input values in this case. Are these input values all different? Yeah, so it is a function. The input values do not repeat. Tables are easy. Just look down that. But what about ordered pairs? We've got -1, 0, 2, and 3. Are those all different? They are all different, so it's a function. Same reason. Questions on those? What about C here? Why is it no?
Because there's 2 keys.
It's no because the input value of 1 repeats. What about D? No. Same reason. What about E? Why not? Because it's y squared. Anybody know what this function looks like? What it's a graph? Sideways parabola would be y squared equals.
That's a circle.
Not way. It's a what?
Circle.
This is a circle with a radius of what?
3.
3. You guys, that's part of. We don't look at conic sections anymore. Circles is a conic section. I don't know that you looked at equations of circles, but this is a circle. So if you have a circle with a radius of 3, this is what the graph looks like. It fails the vertical line test. What about x equals 5? Is this a function? No, all the x values are 5 in this whole entire T-chart. 5 pairs with every single y value we can. So this is no. What about this one? Yeah, what's it look? It's a parabola, y equals. And what about this one? What type of function is this? It's an absolute value that's V-shaped, and it is yes. And I have a note that says any function with y by itself will be a function. As long as y is not squared to the 4th, it's gonna be a function. Here's the vertical line test. When a function is represented graphically, the vertical line test can be used to determine if a graph is a function. If any vertical line crosses the graph more than once, the graph does not represent a function. We showed that up there in that circle. Questions on whether something's a function or not? All right, function notation is where we replace the y with f of x. For example, f of 5 denotes the y value that corresponds to x equals 5. So if a function x is the independent variable, in a function, x is the independent variable, y is the dependent variable. Did you guys talk about this in Algebra 2 at all? Briefly, like if we're talking about how fast an elevator goes up, the distance an elevator goes up from the ground. Distance depends on the time, because if it's 0 seconds, that elevator's not moving. But if it's 2 seconds, the elevator is moving. So the distance depends on the time. Evaluate each function at the given values. So the first function is f of x equals 3 minus x squared. They want us to find f of 2. What's that tell me to do?
Plug in 2 for x.
Plug in 2 for x. You guys are good. So 3 minus 2 squared, 3 minus 4, we get negative 1. Awesome there. Well, what about b? Same thing, except what do I plug in for x this time? X minus 1. So we get 3 minus the quantity x minus 1 squared. You need to simplify that. How do I do x minus 1 squared? You put them beside each other, x minus 1 times x minus 1. Doesn't anybody want to tell me that it equals x squared plus 1? Good job, because many students tell me that if it's x minus 1, they just square the first, they just square the last. This is also one of our special products, that if it's x minus 1 squared, you square the first term. The middle term are these two multiplied together and multiplied by 2. That's negative 2x, last term. Do you get the same thing if you distribute? X times x, x squared. X times negative 1, negative x. There's a negative x. There's a positive 1. X squared minus 2x plus 1. Either way works. When it's x minus 1, if you remember that it's a first term squared, the two terms multiplied together doubled, last term squared, it saves you a little bit of work. If you want to be more precise with yourself, want to make sure you do it right, write it out. I don't have a problem with that either. But what you do not need to make sure is, since that's a minus sign, you're subtracting the whole thing. So it's 3 minus x squared plus 2x minus 1. It's not just the x squared, so make sure when you see minus, you put parentheses there. And so I've got negative x squared plus 2x plus 2. questions there?
Why is the one negative before your answer? It's x, negative x squared is 2x squared. Why is it negative 1?
Right here,
Yeah.
because I'm subtracting the whole quantity. So I have to take this negative sign and distribute it to everything inside this. Then we have piecewise functions. I want to find what is f of negative 2. Do I plug it into both of them? No, you find out where this negative 2 falls. Is it less than negative 1 or is it bigger than negative 1? It's less, so you use this top equation here.
Why is it F?
Oh, because I just typed it wrong. So make that an F. There you go. What about B, f of negative 1? Because it's less than or equal to negative 1, we use the top one. Then f of 3, bottom one, because 3 is greater than negative 1. So 3 squared gives us 9. Questions there? All right. Find the value or values of x for which f of x equals g of x. How do I do this? Set them equal to each other. X to the 4th minus 2x squared equals 2x squared. So what if it has a power? How do I solve equations that contain powers? They have to be set equal to 0. So I'm going to subtract 2x squared from both sides. So x to the 4th minus 4x squared equals 0. Got an x squared. So I can set each of those factors equal to 0. X squared equals 0, x is 0. X squared equals 4, so x equals plus or minus 2. So answer is 0, 2, negative 2. Don't forget, when you solve an x squared and you're square rooting, you've got plus or minus. Only when you square root, solve an equation, do you do plus or minus. Questions? All right, then I think this is the last thing we're going to talk about is domains. Sorry, it's not. But domains, I give you 3 different situations where you have to find the domains. When you look at and I ask you to find the domain, it is easier to ask yourself what won't work than what works. So the first example, we'll have some restricted domains. Sometimes we won't. If it's a polynomial function, it's going to be all reals. Do you see a polynomial function in any of this? Polynomial means it's just all powers. Well, this one right here. This is a polynomial. This is a parabola. What's the domain of a parabola? All reals. There's no number I can plug in here that won't work. So this is going to be all reals. I'm going to write it with the R with the two lines. Where we start getting into restricted domains is when we have a square root and when we have a fraction. What cannot happen when we're dealing with a fraction? Can't have 0 on the bottom. So for this one, x squared minus 1 cannot be 0. Can it be any other number in the universe? Yeah, I can divide by decimals, I can divide by fractions, I can divide by whole numbers. I just can't divide by 0. So x squared cannot be equal to 1. So this is going to be all reals except x cannot equal what?
Negative
1 or negative 1. So we have restricted domains when we have fractions. We also have restricted domains when we have square root functions. What can't I take the square root of? A negative number. Can I take the square root of 0? Yes, the square root of 0 is 0. So what's underneath here has to be greater than or equal to 0. So x has to be greater than negative 2. Any number less than negative 2 will give me a negative under that square root, and I can't square root a negative. Questions there? All right, yes, I threw that word calculus in here. One of the basic definitions in calculus employs the ratio known as the difference quotient of f of x plus h minus f of x over h, provided h is not 0. If you're going to take calculus, we'll get into it and talk to this a little more. But what you need to know is when you go to calculus, I expect you to know how to do this. So how do I find f of 5 plus h minus f of 5 over h? Well, here's my f function. So what am I going to do first? Where does this go?
For x.
That goes in here for x. So that's going to be f for 5 times 5 plus h minus 5 plus h squared. Minus what I get when I plug in 5. So that's going to be 5 times 5 minus 5 squared. And then it's all over this h right here. Now we're going to do the math. 5 times 5 plus h. 25 plus 5h. Here's that minus. We have 5 plus h squared. Square the first. These two multiply together and doubled. Square the last. Now if you did, said, okay, well, I don't know that rule, Bohnbacher, so I'm going to go over and I'm going to multiply it out like this. Perfectly fine. There's 25. There's 5h. Here's 5h. Here's h squared. There's 25 plus 5h plus h squared, is what I put here. 10h. Yes, thank you. Minus, well, that's 25 minus 25. Which is what? 0, so that cancels out. All over h. Then we're going to simplify the top. 25 plus 5h, distribute negative 25, negative 10h, negative h squared. What happens to those two 25s? They cancel out. Oh, I canceled the wrong thing. So 5h minus 10h, negative 5h, minus h squared over h. And what happens with the h's? All three terms contain an h, so I can cancel out an h, an h, and an h to get negative 5 minus h. If you don't like that, the top has an h in common, and now these h's cancel, you get the same thing. Questions?